Hey guys, this is the 3.1 notes. 3 focuses on certain rigid motions and transformations. So, a transformation is an operation that changes the original object called a preimage. So, you'll hear me say preimage as the original shape or point on a graph or something like that. And then into a resulting object called our image. So the pre-image turns into our image. You might see the image notated as a prime, so it looks almost like a with an apostrophe, and then the pre-image would just be a. Okay, so you would say a prime is the image of a, something like that. Okay, so we can transform points, shapes, and even functions, which you'll transform functions in algebra 2. All right, so right, I talked about we're going to be using rigid motions. Okay, so rigid motions are transformations that preserve side lengths and angle measures. So, right, their directions may change. Um, uh, where they are on a graph may change, but their side lengths and angle measures stay the same. Okay, so essentially the shape slash size does not change. And you can see down here, right, there's a picture of a pre-image and an image, where 1A is a rigid motion. Okay, so this is rigid because it kept the same side lengths, right? This side right here ended up moving to this side, and this side right here, right? And you can see it's the same side lengths. This side moved here, and this side moved here. And B, right? The shape stayed the same, but the size changed. So size changed. So it's not rigid. Okay, those are an example of it getting bigger and then it could get smaller. We'll do that in a different section. Okay, these are focused on rigid motions. All right, so now the first rigid motion we're going to do, which is all of section 3.1, is reflections. Okay, so a reflection is a transformation that reflects each point of in the preimage across a line of reflection. Okay, so if you look at this picture here, say M is our line of reflection, and we had triangle ABC here. Right, when we reflect over it, right, C ends up being the same distance away from that line of reflection, and B is also the same distance away. Right, this distance is the same as this. Right, and A is on that line of reflection. If if a point is on the line of reflection, then it does not move. Okay, so you can see here if point A is on line M, then point A and its image are on the same point. Okay, so you can see A and A prime are the same. Right, B is not on the line, therefore we reflect it over the line of reflection, and it should be the same distance away. All right. The reflection of triangle ABC across line M can be written as, you'll see a large that says the reflection. Make sure it's a capital R because lowercase is going to be rotations. M is the line of reflection. And then you have your original triangle ABC, and then you have triangle A prime, B prime, C prime as your image, right? Image, this is your pre-image, right? In reflections, we know are rigid transformations, okay? And the way these are written are important because that's how they're written on the Math Excels. All right, so what we're going to do now is we're going to draw a quadrilateral FGHJ given the coordinates, and then we're going to first do a reflection over the x-axis. This will allow us to find a general rule whenever reflecting a point across the x-axis, and then we're going to figure out what the rule is for the y-axis. Okay, so let's graph and label FGH. So F is 0, 3. So 0, 3 is here. This is F. G is 2, 4. H is 4, 2. And J is negative 2, 0. Okay, so let's make this quadrilateral. Okay. Now, we're reflecting over the x-axis. So this right here, this red one, is our line of reflection. So, all right, what we're going to do is we're going to reflect it over that line, meaning it's going to be the same distance from the line, just on the opposite side of the x-axis. So J, right, is on that line of reflection, so J prime stays there. Okay. F prime, right, F is 3 away, right, 3 above it, so we're going to go 3 below it. Okay, and this is going to be F prime. G is 4 above it, so we're going to go 4 below it. Here is G prime. H is 2 above, so we're going to go 2 below, so H prime. Then we make our quadrilateral. Okay. Now, let's examine what happened, right? We can see our x's stayed the same, right? Our x for F was 0, 3, right? 0, 3. And then it becomes 0, negative 3. So the only thing changing is our y's. Now let's look at G. G is 2, 4. And G prime is 2, negative 4. H is 4, 2. And H prime is 4, negative 2. So essentially, right, for going over the x-axis, we take the opposite of our y, and x stays the same. Okay, so our general rule for this is we say if we do a reflection over the x-axis, our xy changes to x and then opposite of y. Okay. Now, when we do across the y-axis, right, it's going to be the opposite. Okay. We take the opposite of x and y stays the same. Right, because that means, right, it's our y-axis, so we're changing, if we're on the right side, it's going to the left side of that y-axis, vice versa. So reflection over the y-axis, your xy changes to negative xy. Okay, opposite of xy. Right, so example, right, if I said, right, reflect point A, which is 1, 2, over the x axis, right? 1, 2 changes to, right? Over the x axis is x opposite of y. So we get 1, -2. If I said the y axis, right, 1, 2, we take opposite of x and y stays the same. So it equal -1, 2. All right. The last reflection line that's very important is reflecting over the y equals x line. Right, y equals x line is just, right, a line with slope 1 equal to 1 and y-intercept at 0. Right, so it just slope goes up 1 to the right one or down 1 to the left one. Right, and we have a certain formula we're going to use to find this. So when we reflect over y equals x line, we take the opposite of our x and y's, we flip them. Okay, our y becomes our x value and our x becomes our y value. So, right, we have triangle ABC. We labeled A is at 3, 3, B is at 2, 1, and C is at 6, 2. So if we're reflecting over the y equals x line, we flip our x's and y's. So A prime would be, it would actually stay 3, 3 because it is on the line of reflection. Okay, so it doesn't move. So A prime is here. B prime, 2, 1 changes to 1, 2. So 1, 2. Right, there's B prime. And then C prime changes from 6, 2 to 2, 6. So 2, 3, 4, 5, 6. C prime. Okay, and there is our new triangle. Okay, so we have the rule for x-axis, y-axis, and then reflect, should be a capital R. Reflection over the y equals x line, okay, is equal to xy changes to yx. So reflection of y equals x, xy, right, is equal to yx. Okay, so that's our general rule for reflection over y equals x line. Now, right, I want you to reflect across the y equals x line, so try this on your own. Right, again, your y equals x line looks like this. Right, and our rule is reflection of y equals x changes our xy to yx. Right, so you flip your x and y's. So try and pause this and try it, and then I'll show you the solutions. So this is our solution, right? If you reflected over this line right here, you can't really just count how far away it is because some of them, right, aren't easy to count. So you do have to do it. So right, L was at 0, 2. So it changes to L prime is 2, 0. Right? We just flip our x and y's. Okay, so on and so forth. All right, the last example I kind of wanted to go through is just an example of kind of doing multiple reflections at once. So let's try and reflect one across the x-axis, and then after we reflect it, so this would be our first image, right? Our first new image. Then we're going to continue from this first one and change it to our second, our actual, I guess we could call it image. And that's reflecting over the y-axis. So if we reflect over the x first, and then we take that new triangle and reflect over the y-axis. Okay, so let's just label our JKL. All right, so J we can see is at -8, -1. K is at 2, -9, and L is at -6, -7. Now we're going to first reflect them across the x-axis. So over the x-axis is going to give us our J prime, K prime, L prime. And then you can see the next one's going to give us J double prime, K double prime, L double prime. Okay, so that's how we'll label these things. So across the x-axis, our xy changes to x negative y, right? We take the opposite of y. Okay, so if we do that, right, our -8, -1 changes to -8, 1. 2, -9 changes to 2, 9. And our -6, -7 changes to -6, 7. Okay, so why don't we plot that? Right. J prime is here, right, because we went over the x-axis. L prime, L prime is -6, 7. L prime, and then K prime should be right here, right, because it's 2, 9. All right. All right, now we'll do our over the y-axis. So now we're going to change our primes. Okay, so J prime, K prime, L prime. Their xy changes to J double prime, K double prime, L double prime, and we take the opposite of x now. So we get 8, 1, -2, 9, and 6, 7. Okay, so let's plot those, and then we are done. All right, so if we graph these, we get 8, 1 for J prime, L prime, 6, 7. Sorry, L double prime. Oops, I wrote that wrong. And then K double prime is here. All right. Now, right, can you make a rule that happened to this, right? Essentially, what happened was we change first, we change our x to our y to opposite y, and then we did over the y-axis, so we change it to opposite x. So if you do a double reflection over the x and y-axis, your rule will be xy changes to -y, -x.